Exactly. That's all we need. None of this
They could
47
even be like
questions.
word problems so that we really have to think, but just four.
Yeah. Really make us think really hard.
Yeah.
All right. Well, ready for number two?
I'm still pulling up the quiz.
Oh, no worries.
Google Hangouts really sucks a lot of the bandwidth.
Yes. Yes, it does. It makes the computer think much harder than it needs to.
Uh-oh. Come on. There it is. Okay. Question two.
So I think for number two, it's just the number of people in a randomly selected classroom because the other two are categorical.
Yeah.
Yeah.
Cool.
You said the last one, right? It kind of cut
Yeah.
out there for a second. Okay.
No,
good.
yes, just the last one.
Okay.
All right. I know we've seen this one before. I just can't remember what it is.
Yeah, it's observational.
Yeah, because it's essentially random.
Yeah.
I would say probably because they had no
They,
control over the serials
yeah.
for the first one.
Okay.
No control over the cereals selected or the price of the cereals.
I think it's the serial selected because they're going more on. Well,
Even though it's true.
yeah, I think it is that first one. All right, so for number four, if we change the 12 to a 21, then the median should increase because it's getting rid of the low outlier.
Sorry, what was that? You cut out again.
Sorry, yeah, for number four, it just wants us to change the three, or change the third ID, the male that's 12 years old, to 21. And so if we change,
yeah, that's going to increase the
yeah,
whichever one it is.
yeah, the median will increase.
Right.
All right, so number five, mean is 70, standard deviation of 10, so under 50 minutes. That would be
2 standard deviations away.
Mm-hmm.
So
what would that be?
Of the students?
0.3.
That's, yeah, that would make sense. Or would it be half that actually?
Yeah, it could. Yeah, because it is just under. Yeah, so it'd be 0.15, I believe. Well, I guess 0.2 because it just wants one decimal.
Oh, yeah.
That seems like a very odd answer for that kind of question.
I know. Usually they don't do that.
Yeah.
Watch, we're going to get it wrong.
Exactly. All right. This is stuff from like forever ago.
I know. I'm worried I'm not going to remember this stuff on the test. It's too old.
Yeah, exactly. I haven't done this in how many months? Let me flip back to the beginning of my notebook.
Yeah, my brain only remembers one unit at a time, so.
Yeah, exactly.
Oh man.
So would we be finding the z-score?
Oh yeah, that's. So do we plug into the normal probability applet the 35 or the 0.35 in the area?
That's what I was doing.
Okay.
It gives you 0.935 as a z-score.
Yeah. Oh, then we use that z-score to solve for something. Like we put, the z-score is equal to the formula.
Shoot. Been too long.
Yep. Let's see, so that would mean 0.935 is equal to is equal to 150 or no, is equal to x minus 157 divided by 10.2.
Yeah, I get what you. Yeah, it's coming back.
It's all gonna be there.
I sure hope so.
Yeah, cross our fingers.
Man, I need a pen and paper for this one. Can you grab that? There's a pen in that pair of jeans right next to you. Grab it. That pair of jeans next to you. The pocket, left side. Front pocket, left side. Just check all of it. Nice. So it's going to be like 0.935 equals.
I think it should be the negative 0.935 because it's below our. I guess
below the,
yeah, because 35th percentile is below the mean.
Right. That makes sense. Minus 150.7.
So I got.
Over.
It should be negative 0.935. What did I do wrong? Okay, so it's 0.935 or negative 0.935 times 10.2 because you got to bring the 10.2 over. Then you add the 150.7 and that should give you your answer.
141.163.
Yep, that's what I'm getting.
Okay, not crazy then.
How many? Do we put all 3 in there?
1 decimal place.
1 decimal, so 1 or 1 for 1.2.
Yeah, 141.2. All right.
Garlic. Fix this button.
So if n equals 2, then we don't really know, right? Because n is way less than 30.
It's ridiculously small, so I'd say we can't be sure.
Yeah, I'd say so.
We did one of these just like this.
Mm-hmm. I think we've actually probably seen all of these questions at least once.
That's probably true. They probably just use the same ones.
Yeah, make it easy on us and them.
I remember how to do these. So my question is, do we subtract the claimed value from the
It's the variable minus the mean.
okay.
So 8550 minus
Right.
yeah, all over 12.
Where does n come into play?
I'm not sure. Where does n come into play? Any ideas? Oh, because
So that's where
we're looking for sample z-score, right?
yeah. So you use the square root of 20.
Yeah, gotcha.
Times the square root of shoot. I can't even remember now.
Yeah, well, it's 12 divided by a square root of 20. And then we can, well, I guess we need to do 550 minus 40. Divide that by square root. So for the z-score, I got 2.236.
That's what I got too.
Cool. I don't remember how you find that probability.
So I think we should do the same thing using a new variable.
Using even plugging that in the output.
Not quite.
N equals 50
Yeah.
in our.
Wait. Is that where you find the z-score and then put it in to find the probability?
Yeah, I think so.
But 50 is your n.
Yeah.
Not your probably, or not your area.
Mm-hmm.
50 is the n.
Yeah. So you find that number and then plug that into the z-score on the probability output.
Oh, that's true.
Have you gotten your z-score already?
No, that's what I'm going to do right now. Michaela's just telling me what I need to do. So it's 540 minus, what was it?
8550.
550 equals, divide that by, is it 10 or 12?
12.
By root 50. I got negative 5.893.
Oh shoot, I did mine backwards, but I got positive 5.89.
Oh, sure.
No, you're right. I subtracted the wrong one first. I flipped them, but
yeah, no worries. Well, so that should just give us just shy of 100%, like 99.99 something.
I'm ridiculously.
40.
Oh yeah. So do we round it? Hold on. Do we just do 100 then? For one, I guess.
That's basically what it is. I mean, it's well, the technically here the probability would be 0 because it's the probability that the mean capacity is.
All right, that's.
Or no, you're right because it's greater than the low value. So yeah, it'd be basically it's guaranteed that it will be. So I think it would just be 1.00.
try it. Oh shoot, I remember we went over a question like this and we were all
Yeah.
confused.
I want to say, because I remember you looked it up, I think it's just the probability of committing a type 1 error.
That's what I remember. I'm
I
gonna
know
look it up
Yeah, go for it.
using the good old Google.
Mm-hmm.
Yeah. It's the probability of rejecting the null hypothesis given that it is true. Type 1 error. So,
Yep, type 1 error.
okay.
All right. And for 11,
I think it's the last one.
yeah.
95% confident with the true.
Mm-hmm. We can pick more than one, though.
It's the
But-
last one. And, well, hold on.
I think that, I mean, maybe the middle one, the 95% of 95%,
Yeah.
but that'd be the only other one that might be true. I'm not sure if it is.
Yeah, I'm not sure.
Well, I'll put it down, and then if someone wants to leave it off, then see.
I'll just go for it.
Sure.
It's only worth 1 point.
Yeah, exactly. 46 out of 47 isn't bad.
Yeah, I'll survive.
And then for 12, it should be yes, because the sample mean is normal because the data is normal.
Oh. Oh, because the data is normal. Yeah. That makes sense. Yeah, it even says it in there. So,
Mm-hmm. Let's see. So what number, whatever we're on here, 13. Which test would that be, do you think?
a difference of means, I think, because we have to take the mean of his.
Because it only gives us one set of values, just column A.
Right, but then we have the mean return of the S&P stock industry or whatever stock index is 0.95.
Yeah, that's true.
And compare it to that one, which I think is a difference of means, or it might be two sampled something or other. I can't remember. I remember. Can't even remember how this is done.
Yeah, I don't remember either.
Well, we know that it's arbitration panel compared a sample of 39 months of the investor's returns. Oh, it's a paired sample.
Yeah, because we're comparing two averages basically.
Yeah, and not only that, but we know it's paired because they compared a sample of 39 months to the same months of the
Yeah, that's true.
stock index.
Mm-hmm. So I guess I just don't quite know where to plug. I know where to plug the rate of return, but then where do I plug in the?
For the null hypothesis, we need to put it as
0.95.
Yeah, confidence level 0.95, and then the null hypothesis needs to be 0.95, with the type of test being
Not equal to. Or would it be? I guess it'd be less.
versus, or was it?
Well, because the
No,
hypothesis is to see if it's significantly
worse than or something.
Yes, I would say it's less than.
Yeah, less than. Shoot, where'd my page go?
So for variable 1, it's 39.
I gotta finish plugging in the numbers still. 1.106.
It doesn't give us the standard deviation though, does it, for the Standard and Poor?
For which one?
Because I know on rates of return we can find a standard deviation, but
Right.
what we can't for Standard and Poor. Does it give us one?
Oh, does it need one? Shoot, maybe I'm doing the wrong test.
Well, because I'm just not sure where to plug things in at, because we have all of our variable 1s, but then the variable 2, it only just gives us one mean.
Just use the summary statistics. I don't use the ones to the side of there. I just plug in all the information that we have into the other boxes.
Yeah.
At least I think it does the same thing.
Yeah, it should give us the same thing. Oh, so then we just need to find the mean of the rate of return.
Yeah.
So for the mean for the rate of return, did you get negative 1.106?
Yeah, that's what I got.
Okay, negative 1.10. So then for the p-value, do you get 0.663. That sound right?
Differences need to change.
Oh, I need to change that to 39.
Am I using the wrong thing now? What the heck even is the p-value? Are you using the paired sample t-test? Am I using
That's what I'm in.
Oh, there it is. What did you say your p-value was?
Well, once I change this, I've got 0.869.
Oh shoot, I've got like 0.019.
Well, let's see. So for your n values, you've got 39, right?
Oh, you had 0.9806 something.
For the p-value,
Yeah.
I got 0.869.
Oh shoot, I just did something wrong then. Okay.
So do you have 39 as your n values?
Yeah.
And then what are your means for 1, 2, and differences?
Like for the variables,
Yeah.
they don't show up because those are just from the variable table to the left.
Well, if you plug in, I guess if you plug in your means, then I guess it should just plug in basically.
You need to delete that data.
I thought those were two separate tables.
Yeah, I guess they are. So I guess what are you plugging in where then? Because I'm not sure what.
So under the summary statistics, I have the mean as negative 1.10, whatever. The standard deviation is 5.9996 or something. N is 39. Then under that, the confidence level is 0.95. I think that's what they asked us.
Yeah, 0.95, 0.95, and less than.
Yeah.
Oh, so you get 0.019 is your p-value.
Yeah.
Gotcha. I think that's probably right.
0.019, right?
Yeah.
3 decimal.
Cool. So for number 14, he's comparing, I think he's just comparing their income.
Income of each one.
Yeah, and so I think it's probably independent because although they are married, their incomes are totally separate. And where he's testing for income, then I would assume it's that.
I thought the
Not dependent.
Shouldn't be.
Trying to think. I thought dependent was knowing who is in one study gives away who is in the other study.
Well, yeah, and that's true.
So,
but I guess the thing that I'm looking at is where he's just mostly looking at the income more than anything. Well,
but the sampling itself is dependent.
Yeah, that's true. Yeah, you're right. The sampling is dependent.
Whereas it's true. Their incomes are completely independent, but the sampling is what they're asking about.
Yeah, that makes sense.
Oh, these airline ones.
Mm-hmm. Is that one same paired sample?
I think so, because you're testing the same one like 90 days later. I haven't even read it, but I remember.
Yeah.
Yeah.
So I think it looks like it wants the 90-day first and then the 14.
Okay.
I guess it theoretically shouldn't matter, but
At least this one we can just plug in,
yeah.
copy and paste.
I have no differences. What do you do?
Okay. Do you have all the information in there?
Getting there. How did you?
Mine-
E5?
Yeah.
Drag.
Yeah, I think so. It's a long. Good job.
There we go.
And
And
91 minus 4, I think.
-4.
Or is it 91 minus 1?
2. Each of them are missing 2. 88, so 86 is our N.
One in here that's blank.
What's that?
Like, pull up your Excel file
Yeah.
for ticket prices. Cell number 13 have a blank spot for the 90-day ticket price.
Yeah. It says on some of them that there just isn't a. I guess that there's just not a
There's no about. Okay.
yeah.
I won't worry about it.
Yeah. Just as long
Yeah.
as you keep them separated out, like leave the blank space once you copy it over.
Right. I just, when I pasted it, I saw a blank space and I thought, oh no, I did something wrong.
Oh,
Pasted
yeah.
it. I deleted it all, re-downloaded the file.
Oh,
Bummer. You see the 90-day ticket prices were variable 1, right?
yeah. I think that's what it wants. So then the mean is what?
The mean difference?
Yeah.
I got negative 25.946. Doesn't look like it pastes well. A lot of holes.
Is that including the values where, because I guess the average or the mean that I'm getting for the whole thing is, I think 24 something.
Okay, let me try.
Yeah,
Delete
negative
those.
negative 24.242 is what I'm getting.
Yeah, there was two that didn't have any.
Mm-hmm.
I deleted those, but mine didn't change. However, my first like 5 boxes don't show a difference.
I think that's from deleting the prior variables just in the stock sheet, and when you do that, it deletes the formula as well.
Gosh dang it. Okay.
But if you go over to the first difference line for variable, like on C5, if you do equals parenthesis
Yeah.
A5 minus B5, then it'll give you your number. And then if you get your little black cross in the corner, you can drag
Yeah.
that down. It'll do it.
So what did you get for your mean then?
I got negative 24.242.
Oh. Dang it, I still got it wrong. Mine's now negative 24.611. Let's see. Or else there might be a hole or something. No, now it doesn't say anything. I don't know. I don't understand. All right. Final thing. I'm going to try and close it and reopen it.
Yeah.
Without saving, obviously. Shoot, which one was that? The quantitative inference procedure?
Yeah. Yep.
Okay. Proving to be too hard. That's not true. Okay. I still got negative 24.611.
Interesting.
Are you
And I
deleting
went,
the empty boxes?
what was that?
Are you deleting the empty boxes?
Yeah, I deleted those ones too.
I think you need to leave the empty boxes.
Even when I leave them, it doesn't change the mean difference.
It would change. It should change them because if you're deleting the empty boxes, then it's moving the other numbers up.
Oh, I see what you mean.
So then the differences
The
are.
number. You don't mean deleting the number inside it. You mean delete that column, that row of them.
Yeah.
Okay, I'll try that. That's probably the problem.
So if you just copy and paste from the other Excel sheet and just leave all of the empty spaces, then it should compute. Where holes for these shoes? Mm-hmm.
Okay, now my Excel's just tripping. Whatever. I mean, I was close. What did you say you got? I'm just going to put it down.
I got, well, for the mean, I got negative 24.242.
Okay.
And then the standard deviation, I got 140.551. But I'm not sure what we put in for. I mean, assuming that our confidence level is 0.95 because it doesn't specify otherwise.
Yeah, that's convenient.
I'm not sure what the null hypothesis would be, though. Would it just be 0?
0 and then not equal to. Or
Okay.
equal to. Got too many Excel files open. All right, what did you say your standard deviation was? I forgot what it was.
Standard deviation is 140.551.
All right, hopefully that's it. My t-value is negative 1.60, or p-value. Sorry, we're looking at the p-value. P-value is 0.111.
I got 0.105. What did you put in for your ends, for your variable 1, variable 2, and differences?
I put in no ends. That would change things.
You should put in 88, 88, and 90.
For which one?
So for variable 1, it's 88 values. For variable 2, it's 88 values. But then for differences, there's 90.
Oh, right. 0.1053.
Yep.
Yeah, that's what I got.
Cool.
Man, that one took a while.
Let's see. And then in this case, P is higher than the level of significance. So that means that there is a difference. So
Yeah.
yes, P value is greater.
Okay.
All right. So I think this one's just pretty much the same as one we did before, where the mean differences is normal because the data is normal.
Oh. Yeah.
I think.
Well, I don't think it'd be the sample size being large because it's
It's
not.
only out of 10.
Yeah.
Yeah. Yeah, so I think it's probably that third one.
Yeah.
Hmm.
Okay.
And then, so for number 18,
See when
they're testing consistency. So they're essentially they're
testing the
testing
distance of zero.
difference. Yeah, so um, the differences of means should be 0. The alternative would be that they are not equal to 0.
So the third one.
Yeah. And then on 19, I think just from seeing this a bunch of times, I think it's the one where it's 95% of all 95% confidence intervals contain the true mean.
Yeah,
I'm still not sure why that is,
I don't know
but
why, but I know that when I see one like this, usually in the 95% of all 95%. So,
yeah. All right, getting into the p hat. Good stuff.
I did not like this chapter.
It was a rough one.
There it is.
So, in order to know that p hat is normally distributed, that one we use.
That one's the n times p hat, I believe, is greater than or equal to 10.
Right. And so would we then just take 10 and divide it by 4 over 5.8?
Yeah, so 4/5. So
So I get 12.5 then.
yeah, 12.5.
Okay.
That is correcto.
I thought, so when I was doing those on the assignment, I wasn't entirely sure that's the way it was supposed to be done. I thought I was just doing some crazy math that I have thought of.
Oh, yeah.
I remember getting some of them right, so I was like, maybe not.
Yeah, maybe it works. I don't know.
Maybe I just created a new way of solving this problem, and I should bring it before some mathematician.
Exactly.
No.
The Heiner principle.
Yeah.
Alrighty, so for 21,
So this is the same sort of thing, but
yeah,
Yeah.
exact same. So I think in this case, 40 times 0.25, that equals 10, so that should be
yeah.
satisfied.
Man, how many questions are there on this thing?
47.
Holy crap, we're not even halfway done.
I know. At this point, I'll just kind of take whatever grade we get and go with it.
For real.
Close enough to the end, it's not going to change a whole lot anyways.
Yeah.
All right.
Plus, we're here at the end of the semester.
Yeah.
That in and of itself is an accomplishment.
So I think for number 22, it is the third option, the 51.2% of all the gametes in the dog's
Okay.
testes have the male chromosome.
I think that's what we're trying to determine. So
Yeah, that one's just kind of based on the prior information more than anything.
math included in that one.
Yeah. All right. So is this one just a p hat equals x over n, or no? That's too simple.
Well, we're comparing two proportions.
Mm-hmm.
Yep, that's as far as I know.
Well, I know that there is an equation for two proportions, and I think that will yield a z-score. So maybe you just, or no, that's a confidence interval. Oh, well, I don't know.
The Excel sheet has room for x1, n1, x2, n. We don't have all that information in this equation, do we? Or maybe we're just using a percentage then? Can we just use 0.5 as the x1?
Which test are you looking at?
So I'm looking at where'd it go? The two proportion.
Oh, yeah. What's that under? Is that quantitative what?
It's the categorical data analysis.
Categorical data. Gotcha.
I actually do think it's the one proportion though. Because that's all the variables we have.
Yeah. So is the null hypothesis the 0.45 then?
Yeah.
Okay.
95% confidence, right?
We can assume so, yeah.
Guess we'll just take a chance.
And then is it a greater than?
I think it's fewer.
Sorry, one more time.
Probability that fewer than 320 of the 700.
Fewer. So yeah, you're right. It is less than. So probability then. Do we plug the z-score in? Is that our next step?
That'd be my guess. Yeah, I'm gonna do that.
I get 0.199, so 19.9%. Oh, it doesn't want percent though, it just wants probability. So yeah, 0.199. What I got.
You got what? 1.991?
I got 0.199.
Or sorry. But is that for both? Is that for only fewer than?
Oh.
Hold on, is this one?
I got for just fewer than I got 0.0996. So that would be rounded up, I guess, to just 0.
Point one, I guess.
Yeah, just 0.100.
Yeah. Shoot, where was that? Where was that question? Okay. I don't know how to do this one.
Which one are you looking at?
Number 24.
24.
Oh, hold on. Would the 0.091 be the value? Probability.
Area to the right. I think it would be the 0.091 times 2, because the area to the right is just 1/2 of that, but it's a detailed test, so I think it'd just be that multiplied by 2. So the 0.182 should be.
Yeah, that makes sense. People are asking for a video already, man.
I know. We're popular.
I know. We're not even done.
I know. Haven't even released it yet, and they already want it.
Yep.
You just start charging, make some money off of it. That'll be $500, please.
Until they hear this part.
Exactly. All right, 25. How many measurements must you have in order to be sure the sampling distribution of X bar is normal? That's just greater than 30, right? That's nothing that's...
Yeah, that'd be my guess.
Nothing crazy special there.
Yeah.
All right, 26.
Oh, yay. Can't remember how to do the. Do you have to run both equations, n times p hat and n times 1 minus p hat, for both the men and the women?
Yeah.
I guess so, yeah.
Okay. So I got the last one. No, because in at least one case, n times 1 minus p hat is less than n. That was for using that equation for the women,
Yeah.
I got like 8.9.
Oh, yeah. Sounds good.
The other ones were all greater than 10.
Yeah. Cool. All right. So for 27, it's just testing testing to see if there's a difference, and so the alternative hypothesis should be that the difference does not equal 0, right?
Yeah, that's what I'm guessing.
Difference of means.
Yeah. That makes sense.
Cool.
All right. Here we go.
All right. 28. I'm not sure on residual.
Is that the predicted weight loss?
I think it might be actual is higher than the predicted.
Yeah,
What is it?
because I believe the residuals are. I can't remember what the residual. The residual is the distance he is from the predicted value, if I remember right.
That sounds right. Yeah.
So I think it's just the. No, I think it's the second.
I think his actual weight loss was
Yeah.
5 pounds higher than the predicted.
Yeah, that's what I was thinking.
All right, let's go with that.
I don't even remember studying that in this class, but luckily in my ecology class, we've been doing linear regression.
Oh, good.
Yeah.
We just barely started doing that like this week, and then it's already on the exam, looks like. So. All right, for 29. I don't know.
So there's B1 and B2. B1 is either the slope or the y-intercept, but I can't.
Oh, yeah, that's right. Let me see. Who wrote that down?
Oh, the Excel file, it probably says it right there.
Let's see. B, okay, yeah, so B naught or B0 is y-intercept, and B1 is slope.
So
in this case, the slope of the regression line was 5 pounds. That means it's
going to be the third one.
Yeah, exactly. As it increases 1, it also increases by 5.
Yeah.
All right, when creating a scatter plot, a residuals plot, and a QQ plot, which 5 are being checked?
Yeah, we can't. I remember this one. The first one we can't know.
Yeah, we can't know that.
And same thing with the independence of the observations, I think. Those were the ones we can't know.
Yeah, but the other 3 we can. So 1 and 3 are not checked, right?
Right.
Okay, cool.
At least I sure hope so.
Yeah, I hope so.
I swear we just did one like this.
Yeah, this one's going into linear regression, though.
Oh, yeah. Regression.
So the response variable is the 14-day ticket price.
Yeah, so the X X is the 90 days, Y is the 14 days.
Which Excel file is this? Is this quantitative inference procedures again?
Yeah, it's the t-test for linear regression.
Okay, I just closed it. So.
No worries. We said 90 is the
90 is X.
Okay.
This one is by the way.
All right.
Hey, this is the same Excel file, I swear.
Yep, exact same.
So the 90 day is the X, right?
Yes.
Just to make sure, when there was a space, you guys left the space, right?
Yep, just leave it alone, let it be, because it basically acts as a 0, essentially.
Yeah. I don't know what I figured.
So I can't remember, what's the sample correlation coefficient?
That's R.
Correlation coefficient is the R variable, if I remember right.
Yeah. Okay. Where's that at? Oh, so that's the 0.846.
You got 0.846?
Yeah.
I got 0.780. My Excel files are just not liking me.
They must not like you. Let's see.
So you didn't delete the ones that didn't have a pair, did you?
Nope. We left just space.
Copy and left it.
Basic.
Okay.
Oh, hold on.
Wait.
I've got some extra values that need to go away. That might help us a little bit. You said 0.780?
Yeah, that's what I got.
Okay, yeah, that's right. There were just some extras from the last data set that I forgot to get rid of off the bottom. So. And then this should be a fairly strong positive association where R is relatively close to 1.
Right. Oh, this is nice.
Scatter plot agrees.
So the y-intercept is 115.
115.640.
Oh.
And the slope is 0.627.
Thank goodness for Excel files.
Mm-hmm.
Then we just put in 14 for X. Oh,
Yeah.
not 14. Oh, yeah.
Is that what it is? Is 14?
No.
Or
Price of a ticket listed 14 days.
oh, so the X would be, I think, 200.
That makes more sense.
So then the predicted value is 240 basically 241.0.
Oh.
I think. I don't know.
Yeah, that's what I got.
So I'm just not sure where the 90 days and the 14 days come in, or if that's just extra
Then
throw you off information kind of stuff.
I think so, because it's just saying at 14 days it's 200, predicted at 90 days. When
Oh,
the cost is 200.
gotcha. Okay, that makes sense. All right. Lower bound of confidence interval, that's 217.11 or 0.188. Or
Where is it?
yeah.
Oh yeah, 217.188.
Well, the only thing I'm not sure about is because if we change that x to like 100, for example, or
Oh,
50,
right.
it changes it. So I'm just not sure what that x value should be.
We have to change it to. I wonder if it's the one found in the y-intercept under B naught. That confident.
The 115.640.
No, your side of it. Confidence interval 80.
Oh, yeah. 80.410. That sounds better. Then the upper bound would be 150.870. And margin of error is just high minus low divided by 2. You get 35.23.
I just put in the upper bound. Hold on.
Oh,
we're using that same confidence interval.
Yeah, the 80.4 and the 150.8.
What did that say?
I got 17.615.
You got what?
17.615. Oh shoot. Was I supposed to divide by 4 or 2?
I think just 2.
Yeah, that's right. My bad.
So 35.23.
Yeah.
Cool. I'm feeling pretty good on most of these. I guess we'll see what happens, but at least I can think that I know what I'm doing. All right, where was that?
Said 35.23, right?
Yep.
Okay, good. All right.
Where was that? Yeah, we wrote that down somewhere. Yeah, I wrote it down. Maybe no one wrote it down.
So for this next one, I think it's the second one. One is slope. 0. The alternative being B1 not equal to 0.
It's slope.
You guys get that one?
So I think so.
It's slope, so
It's got to be
B1.
It's got to be B1. I just can't remember. Is it small b or is it like beta 1?
Oh shoot, I didn't even think about that.
So the difference between B1 and beta 1 is beta 1 is slope in regression, and B1 is slope.
Okay, so that's probably that last one then.
So what's the difference between beta and little b then?
From what
I
I
missed that.
understood from the videos of the last one was that B1 just was slope, and beta 1 is slope in regression.
Okay.
And same goes for beta naught. Beta and beta naught.
Right. Okay.
So then the test statistic of the slope is 11.510.
Yeah.
Cool. E-value is 0.000 basically.
It's ridiculously small.
It's infinitely small. Yeah. So because it's so tiny, p is low, we reject the null. And there is sufficient evidence. I feel like there was one earlier that we did that involved rejecting a null, but we accepted it.
Really?
Well,
It was higher than the level of significance, though.
There was 2 that we've done where we had to come up with or we had to reject or accept something.
okay, that one doesn't matter.
Well, maybe not. I can't find them.
Huh. Oh well.
I know at least one of them, our p-value was higher than the level of significance, and we said yes.
Yeah. I remember that one.
Oh. Yeah. That means we reject the null, which says there is no difference. So yes, there. Okay, yeah, never mind. We're right. We got it right. We checked it. All right, are we ready for 43?
Yeah.
Cool.
So I think this one is a one. It's a 1 sample.
Mm-hmm. And we don't have the standard deviation, so would that make it a t-test?
That's what I was thinking.
Cool. So then this one would be a 1 sample z-test because we do know the standard deviation. For 45.
Sounds like a
Yeah, it'd be I think it'd be a proportion test, maybe just a test of one proportion.
yeah.
Cool. So this one would just be, or for 46, it'd just be 2 proportion, I believe. Because it's the communicative and non-communicative.
10%.
Yeah.
And then the percentages of those.
Yeah. So.
And 47.
Linear regression.
And then I'm guessing if they want to show a linear relationship, they would probably go with the linear regression test.
I guess you. All right. Moment of truth.
What was that?
Moment of truth.
Yep, let's see if I'm going to bed with a good score or a bad score.
Enough. I'm going to bed.
Yeah. Anything above like a 70 at this point, I'm like, okay, good enough.
Ooh.
Not quite above a 70. And you know what? Whatever. What did we get wrong? I feel like it did pretty good.
Apparently, we got quite a bit wrong. I
Yeah.
feel like we did pretty good too, but apparently not.
Yeah.
Don't you just love math classes?
Yes. So apparently we used the wrong upper and lower bound on our confidence interval.
For those last ones that we were doing.
Yeah.
Dang it.
No. For the slope.
Oh, yeah. So it wanted us to use slope. We used y-intercept. So let's see.
The test is next weekend, right?
I'm
Or is
Pretty
it tomorrow? Shoot, now I'm worried.
not sure.
Trying to remember. No, that's right. Final three. Told you. Yeah. Friday. Monday's the official. Okay. Well, I think we only have 30 minutes anyways, and I don't know. Some of these I'm really not sure.
Yeah. I mean, some of them we do know what we did wrong, but yeah, by the time we would have to submit it, we'd probably be down to crunch time. So
Yeah, and I know there's a whole crowd of people that want our answers.
exactly our half wrong answers.
Let's just not tell them we got a bad grade.
Exactly. We'll just say, just go for it. You'll do great.
Yeah, believe in yourself. All right.
Awesome. Well,
It could be worse.
yeah, could be a whole lot worse, but
Oh well,
all right. Well, thank you for the fun and good luck on the test.
for the fun, yeah.
Yeah.
All right. Good luck.
Yep. We'll catch you later.
Yep. See ya.
Bye-bye.